Unit 12.1, 19th Century Society Study Guide. Reasons for the Second Scientific Revolution. Advances in industrial technology, new inventions and innovations in industrial machinery, and the power sources that drove these machines fed an interest in the scientific research, initially to continue to grow capital. What resulted was a rash of basic scientific discoveries that soon flipped even the greatest concepts of Isaac Newton upside down. The steadily increasing and often dramatic material gains generated by science and technology led to a growing faith in the benefits of science. Even ordinary people who did not understand the theoretical concepts of science were impressed by its accomplishments. The popularity of scientific and technological achievement led to the widespread acceptance of the scientific method, based on observation, experiment, and logical analysis, as the only path to objective truth and objective reality. This, in return, undermined the faith of many people in religious revelation and truth. It's no accident that the 19th century was an age of increasing secularization, particularly evident in the growth of materialism, the belief that everything mental, spiritual, or idea was simply an outgrowth of physical forces. Truth was to be found in concrete material existence of human beings, not in faith-based religion or unrealistic hope. Charles Darwin. Charles Darwin, like many of the great scientists of the 19th century, was a scientific amateur. Born into an upper middle class family, he studied theology at Cambridge, while pursuing an intense side interest in geology and biology. In 1831, at 22, he accepted an appointment as a naturalist to study animals and plants on an official Royal Navy scientific expedition aboard the HMS Beagle. Its purpose was to survey and study the land masses of South America and the South Pacific. Darwin's job was to study the various forms of plant and animal life. He was able to observe animals on islands virtually untouched by external influence and compare them to animals on the mainland. As a result, Darwin came to discard the notion of a special creation and to believe that animals evolved over time and in response to their environment. When he returned to Britain, he eventually formulated the explanation for evolution in the principle of natural selection, a theory that he presented in 1859 in his celebrated book on the origin of species by means of natural selection. The basic idea of this book was that all plants and animals had evolved over a long period of time from earlier and simpler forms of life, a principle known as organic evolution. Darwin was important in explaining how this natural process worked. He took the first step from Thomas Malthus' theory of population. In every species, many more individuals of each species are born than can possibly survive. This results in a struggle for existence. As more individuals are produced than can possibly survive, there must in every case be a struggle for existence, either one individual or another of the same species, or with the individuals of a distinct species, or with the physical conditions of life. Those who succeed in this struggle for existence had adapted better to the environment, a process made possible by the appearance of variance. Chance variations that occurred in the process of inheritance enabled some organisms to be more adaptable to the environment than others, a process that Darwin called natural selection. Those that were naturally selected for survival survived. The unfit did not and became extinct. The fit who survived, in turn, propagated and passed on the variations that enabled them to survive until, from Darwin's point of view, a new separate species emerged. Darwin was not able to explain how variance first occurred and did not arrive at the modern explanation of mutations. In The Origin of Species, Darwin discussed plant and animal species only. He was not concerned with humans themselves and only later applied this theory of natural selection to humans. In The Descent of Man, published in 1871, he argued for the animal origins of human beings. Thus, humans were not an exception to the rule governing other species. Thomas T. H. Huxley. The biologist Thomas Huxley, known as Darwin's bulldog, became the chief spokesman for Darwin's ideas. He debated with, among others, the Bishop of Oxford. Darwin was denounced with less than fairness for saying that men came from monkeys. It was feared that all grounds of human dignity, morality, and religion would collapse. Gregor Mendel. Meanwhile, Gregor Mendel, a monk patiently experimenting with cross-pollination of garden peas in his Augustinian monastery, arrived at an explanation of how heredity operates and how hybridization can take place. Unlike Darwin, his findings, published in 1866, were ignored until 1900, when they were rediscovered and became the basis for new science of genetics. Mendel's ideas foreshadowed the amazing breakthroughs in the scientific study of heredity and control over genetic materials in the second half of the 20th century. Changes in medical care. The application of natural science to the field of medicine in the 19th century led to revolutionary breakthroughs in healthcare. The first steps toward a more scientific basis for medicine were taken in Paris hospitals during the first half of the 19th century. Clinical observation was introduced, which consisted of active physical examination of patients. Still, the major breakthrough towards scientific medicine occurred with the discovery of microorganisms or germs, the agents causing disease. Louis Pasteur. The germ theory of disease was largely the work of Louis Pasteur, a French chemist. Through experimentation on fermentations, he soon proved that various microorganisms were responsible for the process of fermentation, thus launching the science of bacteriology. Government and private industry soon took notice. His examination of a disease threatening France's lucrative wine industry led to the development of a process later known as pasteurization for heating a product to destroy the organisms causing spoilage. In 1877, Pasteur turned his attention to human diseases. His desire was to do more than simply identify disease-producing organisms, led him in 1885 to preventative vaccination against rabies. This was followed in the 1890s with vaccines against diphtheria, typhoid fever, cholera, and plague. Joseph Lister. Pasteur's ideas were furthered by British surgeon Joseph Lister, who developed the antiseptic principle. Lister perceived that bacteria might enter a wound and cause infection. His use of carbolic acid, a newly discovered disinfectant, proved remarkably effective in eliminating infections during surgery, thus ending the problem known as surgery gangrene. Ivan Pavlov. Ivan Pavlov was a Russian psychologist who conducted a famous series of experiments in which he conditioned dogs to salivate automatically at the ringing of a bell, once they had become accustomed over a period of time to associate the sound with the serving of their food. Pavlov's observations were important. They implied that a great part of animal behavior, and thus human behavior, could be explained on the basis of conditioned responses. In the case of human beings, these responses, which humans make automatically by virtue of their earlier environment and training, and not through choice or conscious reasoning. Sigmund Freud. Freud put forth a number of theories that undermine the optimism about the inherent rationalism of human beings. In his major 1900 work, The Interpretation of Dreams, Freud described the basic foundation of what came to be known as psychoanalysis. According to Freud, human behavior was strongly determined by the unconscious, by former experiences and inner drives of which people were largely oblivious. To explore the contents of the unconscious, Freud relied not only on hypnosis but also on dreams. However, the latter were dressed in elaborate code that had to be deciphered if the contents were to be properly understood. But why did some experiences whose influence persisted in controlling an individual's life remain unconscious? The answer was repression, a process by which unsettling experiences were bottled from conscious awareness but still continued to influence behavior because they had become a part of the unconscious. To explain how repression worked, Freud elaborated an intricate theory of the inner life of human beings. According to Freud, a human being's inner life was a battleground of three contending forces: the id, the ego, and the superego. The id was the center of unconscious drives and was ruled by what Freud called the pleasure principle. As creatures of desire, human beings directed their energy toward pleasure and away from pain. The id contained all kinds of lustful drives and desires, crude appetites and impulses, loves and hates. The ego was the seat of reason, and hence the coordinator of the inner life. It was governed by the reality principle. Although humans were dominated by the pleasure principle, a true pursuit of pleasure was not realistic. The reality principle meant that people rejected pleasure so they might live together in society. The superego was the locus of conscience and represented the inhibitions and moral values that society in general and parents in particular imposed upon people. The superego served to enforce the ego to curb the unsatisfactory drives of the id. The human mind was thus a battleground. Ego and superego exerted restraint upon the id and repressed what it wanted to. The most important repressions were generally sexual, and he went on to develop the infantile theories of sexuality, embodies in the Oedipus complex and the Electral complex, which described an infant's craving for exclusive possession of the parent of the opposite sex. Repression began in childhood, and psychoanalysis was accomplished through the dialogue between therapist and patient, in which the therapist probed deeply into the memory of the person in order to retrace the chain of repression all the way back to its childhood origins. By making conscious mind aware of the unconscious and its repressed contents, the patient's psychic conflict was resolved. Marie and Pierre Curie. Marie Curie and her husband Pierre, who discovered an element called radium, gave off rays of radiation that apparently came from within the atom itself. Atoms were not simply hard material bodies, but small worlds containing such subatomic particles as electrons and protons that behaved in seemingly random and inexplicable fashion. Inquiry into the volatile process within atoms became a central theme of new physics. Max Planck. Building upon this work in 1900, a Berlin physicist, Max Planck, disclosed a discovery that he believed was as important as that of Newton, which was gravity. Planck rejected the belief that a heated body radiates energy in a steady stream, but maintained instead that energy is radiated discontinuously in irregular packets called quanta. The quantum theory raised fundamental questions about the subatomic realm of the atom. By 1900, the old view of atoms as the basic building blocks of matter was being seriously questioned, and Newtonian physics was seriously in trouble. Albert Einstein. A German born patent officer working in Switzerland pushed these new theories of thermodynamics into new terrain. In 1905, Einstein published a paper entitled The Electrodynamics of Moving Bodies, which contained his special theory of relativity. According to this theory, space and time are not absolute, but relative to the observer, and both are interwoven into what Einstein called a four-dimensional space-time continuum. Neither space nor time had an existence independent of human experience. As Einstein once explained to a journalist, it was formerly believed that if all matter disappeared out of the universe, time and space would be left. According to the theory of relativity, however, time and space would disappear with all material things. Moreover, matter and energy reflected the relativity of time and space. Einstein concluded that matter was nothing but another form of energy. His famous E equals mc squared, that each particle of matter is equivalent to its mass times the square of the velocity of light, was the key theory explaining and later locking the vast energies contained within the atom. This theory ultimately led to the atomic age. Albert, the father of pessimism, was the German philosopher Arthur. Albert. In the world as will an idea is the dominant force is that the dominant force in the universe is our own continually dissatisfied will, continually striving to survive and fulfill our own desires. Human nature, and thus the world, wasn't driven by any concrete rationality because our own nature is truly irrational due to our conflicted will, he says. The world is the scene of strife and constant war where the strong devour the weak. The only way to suppress these natural destructive nature was for the individual to withdraw in aesthetic contemplation. And in many ways, this guy borrows more from Buddha and the Vedic text of India than Western mentality. End of part 1.